So you can imagine that here the electric field which is along the z axis and the magnetic field which is along the y axis, but the thing is that here which may be alternately changing here y and z or z and y, but the propagation of this wave along the x direction only. Okay, but the thing is that the component of electric as well as the magnetic fields both are perpendicular to each other, and the propagation of the wave is also perpendicular. Is it clear? So this type of wave you can call it as a electromagnetic wave. Okay, so in electromagnetic waves, the electric as well as the magnetic fields which are varying periodically. Okay, you can see that how it is to be varying with respect to time, the components of the electric field and magnetic fields. Okay, so whereas in the case of light waves, you can see that how the light waves are to be propagated. Okay, whereas the electromagnetic wave, two components, propagation in one direction. Light wave, let you compare these two. Next is the Huygens principle. Yesterday we have been discussed about the Huygens wave theory. Okay, so Newton's corpuscular theory, which is failed to explain about the interference, diffraction, polarization, all these things. But it is explained successfully the phenomena of reflection, refraction, rectilinear propagation of light, all this. But whenever the wave theory which is enter into the picture here, whatever the failures which have been seen by this corpuscular theory, so based on this Huygens theory, wave theory, all the phenomena which was successfully explained. Okay. So particle wave means wave includes the particle. Corpuscular theory only particles. So you can see that Huygens theory, Huygens principle for a light which is having such a frequency, and every point on the wave front which is act like a secondary source of spherical wavelets. Secondary source of the spherical wavelets with the same frequency. Okay, so you can see how the spherical wavelets which are to be spreading out here within a same initial phase. Okay, next one. So whereas the wavefront at a later time, the position is which is in the linear superposition of all these waves. So what do you mean by a principle of superposition? When two or more waves traveling in a medium which are to be superimposed, then the resultant displacement at any point which is equal to the algebraical sum of the displacement of two superimposing waves. So this is known as principle of superposition. Okay. Suppose the displacement of the first wave is y1 and the displacement of the other wave is y2. What is the total displacement of these two waves? Y equals to y1 plus y2. Okay, na? So you can easily observe that the displacement are the amplitudes which are maximum, whereas another wave, and this is in Well, previously those are in same phase, but here the phase is opposite. Okay, so you can see that one is in upward direction, other wave which is in downward direction. What is the total displacement? Total displacement of the wave. What is that? Y1 minus Y2. Nothing is there. So the resultant displacement due to these two waves, which is given by y equals to y1 plus or minus y2. So when do you consider plus positive sign? Means when these two displacements which are in same direction, and minus is opposite direction. Okay. Next is the interference. So when two light waves superimpose, then the resultant amplitude, okay, square of the amplitude, which is nothing but intensity. So in the region of superposition, which is different than the amplitude or the intensity of the individual waves. So you can see which one is a constructive, which one is a destructive. You can observe two waves which are in same phase, constructive. The two waves which are opposite to each other, yeah, that is destructive. Is it clear? In the case of constructive, a bright intensity of light is to be observed. Whereas in other side, that is a destructive, those two are in out of phase or in opposite, then the light intensity becomes 0. Okay, you can easily observe the diagram. Is it clear? So the modification of the distribution of amplitudes. In the region of superposition, which is called interference. So there are two types of interference, depends upon the intensity. So you can go for that. One is the constructive, another one is the destructive. So you can see when the resultant amplitude, which is equals to the sum of the amplitudes, then it is the individual waves and the intensity of light which is maximum. That means which is in bright. There is a bright, such a intensity it is to be maintaining, of light is to be observed. Then that type of interference is known as constructive interference. Okay. So in which bright bands are formed. Is it clear? When the resultant amplitude, which is equals to the difference of the amplitude. In previous, sum of the amplitude, that is bright. Here the difference of the amplitude. That means the intensity becomes 0, which is minimum. So that there you cannot able to observe the intensity of the light. There is no light at all. That means that is completely dark. That is 0. So that interference, which is uh, corresponds to the here destructive interference. Okay. Next, Young's double slit experiment. You can see here. What is Young's double slit experiment? So there only you can able to observe the case for Young's double slit experiment. Madhu, I'm in class. Phone just. So here you can observe there is a slit here and there is a source of light and there is a slit here. Yes, not. And other two slits are there. S1 and S2. Here there is a screen. Okay. So you can easily observe that how, what do you mean by interference? When two or more waves, such a frequency or intensity of the two or more waves are to be superimposed, then bright and dark bands are to be observed. Okay. So in interference only, there is a constructive as well as the destructive interference is to be takes place. Constructive means bright band, destructive means dark band. Constructive means those are in phase, destructive means those are out of phase. Is it clear? So these are the terminologies. And before discussing all these things. So here that's why this is the center one. Yes, not central maxima. Maxima means bright. Minima means dark. Maxima, minima, maxima. So in above the maxima, here minima, maxima, minima, maxima. Okay. So where the interference, that means you can see here where the light, these are the spherical wavelets, secondary spherical wavelets which are to be incidenting upon this slit S1 and S2. So S1 is also to be generating the secondary wavelets and S2 is also. So these two waves are to be superimposed. So that the crust, first wave of the crust and second wave of the crust are first wave of the trough and second wave of the trough. You can interchange. Crust and trough are to be superimposed. Then here you can see a bright constructive interference. Here also. Okay. What about the minima? First wave of the crust and second wave of the trough. Or the second wave of the crust and first wave of the crust. Those are to be superimposed. Those are in out of phase. Then you are observing destructive. Destructive means dark. Constructive means bright. Is it clear? So from the figure only I am telling all these things. So here what is the figure? Here this one right side. So this is the bright. Immediately dark, bright. Which one? See here. This is the bright, dark, bright, dark, bright, dark. Is it clear? So these are called fringes. This is the bright. Okay. So these you can call it as a fringes. Bright, dark, bright, dark, bright, dark. Okay. You can see here a beautiful picture of the Young's double slit experiment. So these are the primary and these are the secondary wavelets which are in spherical nature. Here S1, here S2. See here how the interference is to be takes place. Is it clear? ఇంటర్ఫీరెన్స్ వ్యతికరణం ఎట్లా ఏర్పడుతుందో మనం చూడొచ్చు. ఓకే, సో ఫస్ట్ స్లిట్ and second slit. This is all about the Huygens wave theory, not by the Newton's corpuscular theory. So y1 is sending, y2 is also. Those are to be superimposed. Then you are finding the interference. Could you explain, could you know that here varies? So here you can see, this is the bright, this portion is dark, here also dark. Getting my point? Bright, and here which is a dark. Getting? Observe. So you can easily know the concept of this interference, how it is happening. Okay, so this is the case. Young's double slit experiment. So what are the conditions for sustained interference? The two sources must be coherent. Amplitude of interfering waves must be equal. The wave should propagate in the same direction. Okay. Two waves are, that is two sources which are incoherent. Amplitude of the interfering waves must be equal. And finally, the wave should propagate in the same direction. So first of all, we will discuss about the here two sources are said to be coherent if their waves have which is having same wavelength, same amplitude, and constant phase difference. And constant phase difference, can see incoherent. See here, first wave, green color, yellow, which are in out of phase. That means which are in incoherent. Next, coherent. Observe the case for coherent. What it? Only such waves on the superposition give rise to interference. So two independent sources of light can never be coherent. Next, reflection of light. Yesterday we have been discussing the reflection refraction phenomenon. So the law of reflection states that the angle of incidence which is equals to the angle of reflection. Theta equals to theta r. See here, this is the smooth surface. This is the normal. Incident ray, reflected ray. Theta equals to theta r. Okay. So reflection from smooth surface which is called specular reflection. If it is rough, diffuse reflection. Is it clear? Specular and diffuse. Next, reflection of light. So you can see this picture. Incident ray, which is making two different medias are there. Medium 1 and medium 2. Rarer and denser. So this dotted line which is a normal. Incident ray which is incidenting at the normal. Okay. So and which is a diffracting. Diffraction means, what do you mean by diffraction? Refraction. The light moves with a different speed through a different media. So when it is moving from the one media to the another media at the normal, the light ray which bends. Okay. So that is the phenomena for the refraction of light. Okay. Incidenting, refract. See this. Bending of light. Next is the what are the basic properties of refraction. So this may be asked as a short question. When a light ray which is enters a media where its speed decreases, it's bent towards the normal. If speed increases, bent away from the normal. Okay. So speed decreases means that may be a denser. Speed increases means that may be a rarer medium. And if there is no change in the direction of propagation, there is no change of refraction. So the greater the change in refractive index mu, the greater the change in the propagation direction. So let us, if a ray which may be going from one media to the another media along with the normal, so it is undeflected regardless of the refractive index. Next, Stokes theorem, so which is not in our syllabus. Next, cosine law, most important. Interference in the films by reflection. So you can see that in yesterday m dash like that we have been discussing, and today you can see here GH and G1H1. The thickness of this layer may be small t. So very small t here, small t, below and above. So here AB is an incident ray and NQ is a normal. So if the incident ray which is making an angle I with the normal, and what is the reflected ray? BR is the reflected ray. Okay. But the thing is that the ray which bends when it is coming out from the one media to the another media bends and moves away from the normal. So which one? BC is the refracted ray. BR is the reflected. BR is reflected, BC is refracted. Okay. So in the same media, again, if it is going to be transmitting and reflecting, here also another normal reflecting, CD is also reflecting, and DR refraction is going to be takes place. That means DR, which is the ray which is coming out from the denser to the rarer medium, whereas AB is the ray which is entering from the rarer to the denser medium. That is the case. Next one. So what is the path difference? The path difference may be here path of the BC plus CD. This one. BC plus CD. In the film, this is the film. GH and G dash H dash of a thickness small t, which is indicating the a thin film, minus path BE in air. This one. Okay. So substituting path difference, which may be indicating delta, and the delta of the mu equals to refractive index, BC plus CD minus BE. But you need to calculate the what is the value of the BC plus CD. But according to Snell's law, what is Snell's law, ma? Snell's law. Sin A by sin R. The ratio of the sine of the incident ray to the refracted ray, which is nothing but a refractive index, Snell's law. So sin I, which may be BE by BD, and sin R is FT by BD. So BD get cancelled, remaining is BE by FT. BE by FD. FD. BE by FT. So B equals to, this is the incident ray, this is the refracted ray. So incident sin R by sin A. So which is nothing but the thing. B equals to mu into F. And which can gives you the path difference for this after substituting and doing the calculation part. Mu value becomes, delta value becomes mu of P, that is mu of PF. Okay, this is the P and F. So BC equals to PC. BC is P, same distance. And next is the cos R value, PF by BP. And 2T cos R. Why? Because of BP means here to here, total distance. From B to Q plus Q to P. T plus T, how much thickness? 2T. Cos R value. So substituting BF value. So here delta equals to mu into what is PT? 2T cos. So that 2 mu T cos R. Where mu is the refractive index, where T is the thickness of the film, and delta equals to cos R. So most important short question or essay question. The optical path difference which is given in this equation, which is termed as cosine. Okay. For reflection, other ray is also there, but you no need of this condition. Yeah. So here the optical path difference, which is a transmitted light before that reflected light. We have been calculated the cosine law for reflected light. Now, which is a concept which is related to the Poisson law for the transmitted light. Okay. But if the examiner is going to ask you whether it is a transmitted or reflected light, based on that, you just draw the diagram and give the answer. Okay. So constructive interference 2 mu t cos r equals to n lambda. That is for bright. Okay. Condition is this. If it is 2n plus 1 into lambda by 2, that is for dark. Is it clear? Yeah. So 2 mu t cos r path difference. If it is n lambda, constructive interference, there you may be get a bright one. If it is 2n plus 1 into lambda by 2, there you may be get a dark one, that is a destructive interference. Next one is the colors of thin films. How the colors will appear in a thin films. When a thin film is exposed to white light, that is such as a sunlight, a beautiful colors will appear in the reflected light. Okay. So what is the phenomena behind this? It is to be observing in this. So you need to understand that the examples. Soap bubble. These are the soap bubbles. You can see here. Okay. Daily we are observing these soap bubbles. There only we are observing the so many colors, different colors. But what is the phenomena behind this to get the colors in soap bubbles? That means interference. Okay. So we are getting due to the phenomena of the interference only, as we are getting the colors in bubbles as well as in thin films also. So here let us assume the thickness of the film should be constant, small t. So what is the condition? 2 mu t cos r equals to 2n plus r minus 1 into lambda by 2, where mu is the refractive index and r, which are the variables here. White light has varying with wavelength. Lambda is the wavelength and the mu is also to be varying. And due to the curved nature of the bubble, angle of refraction is also going to be varies. So what is the formula? 2 mu t cos r equals to 2n plus 1 into lambda by 2. So by varying the values of mu and r, which can satisfy the condition for constructive interference of particular. So accordingly, the point will appear bright in the color. Similar way, different points satisfy the condition for constructive and hence appear multicolored. Oil films. Here also same. In case of thin oil films, the surface is flat. So where do you observe? In the rainy season. Whenever you travel on the road, there only you can easily observe that how the colors which are forming, which is, so if any water droplets which are to be here on the petrol or diesel, so there this type of colors are to be observed. Okay. So this is a thin oily film. Next, this is a wedge method. Yeah, this is the Newton rings. Another important essay question for our theory point of view. So you can see this. This is a plain glass plate. This is a plano convex lens. What do you mean by plano convex lens? Convex lens means shape should be like this. Okay. If you are to be cutting this, getting my point? This is convex lens. This is plano. If you cut this, that is plane. So which is a plano convex lens. And this is another a smooth glass plate, which is making an angle theta with the direction of the light. So what is the theta value means 45 degrees, which is inclined at a 45 degrees of an angle. This is another glass plate. Plain glass plates are two. One is at the bottom of the plano convex lens, and other one is the other plain glass plate, which makes an angle theta. That is, theta value should be 45 degrees. So this is the sodium apple lamp, yellow color light. Okay. By this is the traveling microscope. From the traveling microscope, you can easily observe that what is happening. Okay. So in this, you can easily observe that the thing is that here, when plano glass plate, plain glass plate and plano convex lens, which are meeting, which are in contact, where it is contact, you can see. Okay. So this is the plain glass plate. This is a plano convex lens. Plano convex lens, PCL. These are in contact at the center. Toward the center, if you are moving away in this direction or in this direction, between these two, a air film is formed. Okay. So what is the thickness of the air film? It is to be increasing whether if you move right side or left side. Okay. The thickness of the film is to be increases. Whereas if you are going to be keeping this glass plate, so this is the source here. Source is sending the light rays. Okay. Here one convex lens is to be placed here, so that you can easily parallelize the all the light rays in which one direction. So that if it is going to be incidenting upon the plain glass plate, which is the at theta equals to 45 degrees. So that due to the nature of the smooth glass plate, the light rays which are to be reflected downwards towards downwards. That means in downwards, there only we are keeping a plano convex lens, and which is placed on the plain glass plate. So that all the reflected light rays which are to be moving in this direction. But the thing is that these rays which are refraction is to be takes place transmitting in the glass plate. Again, the glass plate, bottom glass plate, which is to be reflecting in upward direction. Okay. So when these two rays, two reflected rays are to be superimposed, okay, are to be superimposed, then interference is to be takes place. In the case of interference, bright dark, bright dark, bright dark. But the thing is that here, this is at center. When plano convex lens and the plain glass plate, when these two are in contact, the thickness of the air film is 0. And if you move towards the right or left side, the thickness of the air film is gradually increasing. Okay. So why these circular rings are total? First one is bright dark band, and if you move away, you are getting like this. Okay. Newton rings. Why it is dark means both are in contact, there only the thickness becomes 0. the air film thickness is 0. So that is the case. So this is the best phenomena and also best example for this Newton rings. You can easily observe. So this is the dark. Why it is dark? Okay. You need to observe that. There is a circular interference fringes can be produced by enclosing a very thin film of air. Okay. So by varying the thickness between the plane glass plate and the plane of convex lens. So which was discovered by and observed by Newton. On his name only we are calling these Newton rings. So this is the experimental arrangement here. So sodium vapor lamp, which is a single colored wavelength, and 5893 Armstrong's wavelength is. So the plain glass plate which is reflecting these rays and they are passing through the lens and interfere with the light rays reflected by convex surface. Okay. So these are coming first, starting coming downwards. After reflection, which is moving in upward direction. So these two are superimposed. Superposition theorem, that is very, very important. So the path difference between the rays which are 2 mu t cos r plus lambda by 2 and here mu is 1 refractive index as well as the for r is also 0, cos 0 is 1. Okay. Refracted ray. So what is the delta value? 2t plus lambda. If it is n lambda, bright one. If it is n plus 1, 2n plus 1 into lambda by 2, that is dark one. See here. For a bright circular, 2t plus lambda by 2. So by simplifying these two equations, 2t equals to 2n minus 1 into lambda by 2. Dark is this one, n lambda. So there is evidence of the bright and dark rings, which depends on the thickness of the air film between the convex and glass plate. Here, the thickness which is equal this along this circle with the point of contact lens of the glass plate, and which are to be concentric circular rings, which are to be formed here. Okay. Which is with the point of contact as a center. So how to calculate the diameter of the Newton rings? So this is the process of the ring, and OC equals to CD equals to R. CD. What is the radius of the ring? It's capital R. So let small t is the area of the thickness film at QP. Here, this is the QP. This is the P, Q and P. So by considering all these cases here, how to calculate the small r value, and if you want to calculate the small r, and which can gives you here r square is 2rt, and the condition for the path difference of the dark ring n lambda. So r value is square root of n r lambda. So half of the diameter, okay, which is the radius, or else d equals to d by 2 equals to r, or r d equals to 2r. Getting my point? So 2 of d is proportional to square root of n. Nth ring, n means d is the diameter. For bright one, same concept, you will get that. So this is about the reflected ray. Starting is dark, whereas the transmitted ray opposite. Okay, that means 2n minus 1 into lambda by 2 is the dark. In previous condition, reflected ray, this is for bright. This condition is for bright. Are you getting? Yeah. This condition is for bright. This condition is for dark. For which light? Reflected. Okay. Interchanging. Please remember. So by doing this calculation here also, you will get this. What are the applications? You can easily find out what is the wavelength of the sodium vapor lamp. Lambda value, you can radius of curvature, that is also to be find out. So dm square minus dn square by 4 into m minus n into r. Diameter of the mth ring and diameter of the nth ring. And also determination of refractive index of the liquid here. The same formula, by using that, you can easily find out the refractive index value, mu value. And if you consider in place of the sodium vapor lamp color is a yellow color light with a white light. What do you observe? White means which is a combination of 7 colors. Okay. When a monochromatic means single colored wavelength. Just now we took yellow colored sodium vapor lamp. So for a mercury, white. Here dark and bright fringes are to be observed, rings. So where the diameter of a ring, which is a friction of the wavelength of light. In case of white light, different colors will be in different. Why? Because of here, white means combination of 7 colors. So that there will be overlapping of the rings with the different colors over each other. So that the first few rings will be clear while other rings appear in different colors. So this is the case. This is for sodium yellow color light, single wavelength. This is for white color. Is it clear? Colored Newton rings are to be observed. This is only single colored. Sources. Okay. So this sends our Newton rings interference pattern we have been discussing. So by tomorrow's class, we will go for the other concept. Okay. I think so. You have been happily enjoyed by seeing all these phenomena which are comes under the Newton ring interference concept. Okay. So that should be a Young's double slit experiment. There only how to calculate the intensity of the light, what is a constructive, what is a destructive interference. Later on, here interference phenomena, Cosine's law, that is for transmitted as well as the reflected ray light. And here also Newton rings for transmitted as well as the reflected light. And how the colors which are formed in a thin films, which and also in bubbles. Okay, soap bubbles. How do you observe? What is the phenomena behind these concepts? Everything we have been discussed. So this ends over the interference first one, and we will discuss other new concept by tomorrow's class. Okay. All right. Thank you. Thank you very much.